Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, my name is Ahmad Farid and we from Group 1 will present the laws of stratigraphy. In this presentation, we will cover and understand what are the definition of stratigraphy, what are the 7 principles of stratigraphy, and identify whether it is useful or not in oil and gas industry. So our presentation will be presented by me, Ahmad Farid bin Ahmad Mushid. Next will be Muhammad Khalif Nur Ahmad. And last one will be Roshan Mahendra. So to begin our presentation, we will begin by understanding the definition of stratigraphy. So the most accurate definition for stratigraphy is a scientific discipline concerned with the description of rock succession and their interpretation in terms of general time scale. By understanding the knowledge of stratigraphy, we can determine the relative age of the layer of the rock. Other than that, we can also know how the forming of the deformation such as folding and bending of the rock layer or strata. So this is a very good example and good for understanding. So by having the knowledge of stratigraphy, we can know the relative age of this rock. For example, whether this rock is younger or this rock is older, or how the bending and the folding of the strata happen. Is the bending old or younger and things like that. Next, we will present and explain about the principle in stratigraphic laws. So there are three people that create this principle. The first one is Nicholas Steno, the second one is William Smith, and the third one is James Hutton. So Nicholas Steno produce about four principles. The first is principle of superposition. Second is principle of initial horizontality. Third one is principle of strata continuity. And the fourth one is cross-cutting relation. For William Smith, he proposed two, which is the law of faunal succession and law of inclusion. And the last one is principle from James Hutton, which is principle of uniformitarianism. Alright, let's get to the first Nicholas Steno principle, which is principle of superposition. Based on the picture right here, the oldest rock will be deposited first and the younger rock will be deposited soon after that. So by this principle, we can know the older rock will be located on the bottom layer of the rock or strata, while the younger rock will be on the top layer of the strata. For real life comparison and example, here are the examples. So we can see many layers of the rock, right? So the older one will be one at the bottom of the layer, and the younger one is the layer above it, and the younger one will be above it also, and so on. So it will be younger as the rock are forming above one another. But when there is erosion occur, there will be unconformity that is formed. So there are three types of unconformities: angular unconformities, nonconformities, and disconformities. Angular conformity are a new deposition that is deposited after folding. For example, okay, this one. They are folding right on this strata, and then there are new layer of deposition above it that will deposit after the folding strata is eroded. So this is the new deposits, and this is the line of angular conformity. So the second one is non-conformities, which is the younger strata above all igneous rock. This is igneous rock that has been eroded by erosion and weathering, and then a new layer of sedimentary rock will be formed above it. The third one is disconformities, which happen when the old layer of sedimentary rock are eroded, and then a new younger sedimentary rock are deposited on top of it. So the second principle that is created by Nicholas Steno is the principle of initial horizontality. Nicholas stated that the new sediments is always deposit horizontally. There is no way in this world that sediment will be deposited vertically except when there is something solid or fluid that is interfering with the way of deposition. Why does it deposit horizontally? It is because by the action of gravity. So, so the youngest rock will be performed horizontally, perfect in a perfect order in a straight line, and the older rock will be deformed by having deformation. For example, on this picture, the layer of rock strata are deformed by folding, which indicate this rock is older. So that's all from me, and this presentation will be continued by my friend Muhammad Khalif. Thank you.
Hello, and my name is Muhammad Khalif. And now we'll talk about principle of lateral continuity, cross-cutting relationships, and law of faunal succession. The principle of lateral continuity states that layers of sediment initially extend laterally in all directions. In other words, they are laterally continuous. As a result, rocks that are otherwise similar but now separated by a valley here or other erosional feature can be assumed to be originally continuous. Here we can see that we can see a pattern here by which we can assume once was a continuous strata. The mid section here is looking to be missing because of erosional feature and destroyed, which has now become a valley. Still, we can see the obvious pattern here that there was once a layer of rock. Moving on to cross-cutting relationships, it states that the geologic feature which cuts another is the younger of the two features. It is also a relative dating technique in geology. Cross-cutting relationship can be used to determine the relative ages of rock and other geologic structures. Here we can see the A is a folded rock strata cut by a thrust fault. B is a large intrusion cutting to A. C here is an erosional angular unconformity cutting off A and B on which rock strata were deposited. D here is a volcanic dike cutting to A, B, and C. E is a younger rock strata overlying the C and D, and possibly the youngest strata in this diagram. F here is a normal fault cutting to A, B, C, and maybe E. Moving on to law of faunal succession. It is it is based on the observation that sedimentary rock strata contain fossilized flora and fauna, and that these fossils succeed each other vertically in a specific reliable order that can be identified over wide horizontal distance. Faunal succession is also a sequences of is also sequences of successive strata and their corresponding enclosed faunas have been matched together to form a composite section detailing Earth's history, especially from the inception of the Cambrian period, which began about 541 million years ago. As we can see here are a collection of fossil assemblage, by which we can categorize it by C, B, and A, and we can know the age range of this known. We can identify the age range of the fossil species by from the younger to the older. Yeah. A fossil containing fossil. Cont- I'm sorry. Fossil also help geologists establish the ages of layers of rock. In this diagram, sections A and B represent rock layers 320 kilometers apart. The ages can be established by comparing fossils in each layer here. Fauna succession is the fundamental tool of stratigraphy and comprises the basis for the geologic timescale. Climate and conditions throughout Earth's history can be studied using the successive groups of plants and animals because they reflect their environment.
Uh, Good morning to Mohammad Elsa Denisa and my classmates. I'm Roshan. I'll be taking over from here. So I'll be talking about the law of inclusion and the principle of uniformism. Okay. So we'll start from the law of inclusion. The law of inclusion states that the rock fragments in a rock is older than the rock which it is in. Okay. So what they're trying to say here is these four pieces of rock fragments here are actually older older than the rock outside of it. Okay, so how is this even possible? Okay, so let me show you in the next slide. Hold on please. Okay guys, how okay, this is how. Now I'm going to show you how this process happens. Okay, so we'll start from here. Okay, so this is rock A. So at the top of surface of it, weathering and erosion occurs. Okay, so it will cause these pebbles, rock fragments of rock A lah. Okay, small parts of rock A fragments at the top of it. Okay, so as time goes on, sediments start to come in. Okay, so sediment starts to deposit on rock A. So what happens is, as time goes on, continue, a new rock is formed on top of rock A, which is rock B, a younger rock, and the pebbles of rock A will be inside of rock B. Will be so that's how they get stuck inside of it lah. Okay, that's how they get stuck into younger rock of B. So the principle of uniformization is okay, quite simple actually. So the definition of it is the natural geological process which occur today have occurred at approximately the same rate and intensity as they have in the distant past and will continue to do so in the future. Okay, so what they're trying to say here is in the natural geological process which is happening today, it is actually happened at the past and it will happen to and it also will happen in the future. Like the same process will be continuing over and over. So this is one example of the principle of uniformization. Okay, this is a basalt. Okay, this is a basalt. Okay, and that is a cooling lava. So if you see basalts if you look at a basalt, actually we all know that basalts are formed through cooling lavas. Okay, so if you look at the basalts formed by cooling lava, they are in the past they are also formed by cooling lava. Now they are formed by cooling lava, and in the future they also will be formed by cooling lavas. Okay, so that's all from me and my team. So this is the summary of what you all have learned. Okay, you all have learned actually the principle of superpositioning, principle of initial horizontally, principle of strata continuity, principle of cross-cutting relationship, the law of faunal succession, the law of inclusion, the principle of uniformization. Okay, so on the behalf of my team, I would like to tell you all thank you. Okay, so now we shall go to the Q&A session. Okay, thank you.